The dreaded 3 or more variable systems. So here's an example of solving a 3 variable system. Now, there are many ways to do this. There are many approaches. You can use substitution, you can use elimination, you can use matrices if you really wanted to. It's usually totally up to you. This example specifically, I'm going to show you how to solve this system using the elimination method, which usually ends up being most students' first choice. The elimination method is all about eliminating a variable in order to shrink things down. So we want to eliminate a variable from off of our page that we can go ahead and reduce our 3 variables down to 2 variables. Okay? So I'm going to go ahead and look at the fact that here one approach is to say I have a 2x and a 2x. All I need to do is make one of them negative. So I'm going to keep my top positive. So this is going to be 2x plus y plus z equals 6. And then I'm going to change the signs of my second equation by multiplying everything with negative 1. So this becomes a negative 2x minus a 3y plus a z equals 2. The elimination method says I have to add these 2 equations together. I'm going to do it old school vertically, and in the process should hopefully eliminate a variable as we go. So here my x's are going to go away. I have y minus 3y is going to give you a negative 2y. X, or z plus z is plus 2z, and 6 plus 2 gives you 8. So what you can see here is I've eliminated a variable, I'm down to 2. Well, I need to do that again. So here I'm going to go ahead and I'm going to keep with my top, but now since I already used the middle one, I have to use the bottom one. And so here I'm going to start with my 2x plus y plus z equals 6, and I'm going to also use the negative 3x plus a 2y minus z equals 5. Now with both of these, I want to cancel my x's because that's what I did in the first one. So here I'm going to have to multiply this top equation by 3, and I'm going to have to multiply the bottom equation by 2. Okay, so I need to go ahead and do that first. So when I do that, 3 times 2 is going to give me 6x plus a 3y plus a 3z is equal to 18. The bottom is going to give me a negative 6x plus a 4y minus 2z is equal to 10. Again, like before, I can now add old school math. My x's go away. I have 3 plus 4 gives you a 7y. 3 minus 2 gives you positive z is equal to 18 plus 10 is 28. So now you can see I have a 2 variable and a 2 variable equation. So I need to start a new system. So my new system is going to involve negative 2y plus 2z is equal to 8, and a 7y plus z is equal to 28. So I'm looking at my new system here, and one of the things that I notice is that if I multiply this bottom system here by negative 2, I can cancel my z's. So when I do that, I'm going to have the negative 2y plus 2z is equal to 8 still on top, but this is going to be negative 14y minus 2z equals negative 56. Just like before, I can do my old school addition, and what I'm hoping here is that a variable will cancel and I can solve for a solution. So here my z's will go away. Negative 14 minus 2 is going to give me a negative 16y. Negative 56 plus 8 is going to give me a negative 48. So here we just found that y is equal to 3. Here's my first solution. Once you find one solution, now you can start working your way back up. So I have one solution, I need to come back into my two variable system. I'm going to choose one of them to work with. Let's go ahead and work with 7y. So I've got 7y plus z is equal to 28. I just found, if you can see here, that y is 3. So I'm going to go ahead and plug that in. This becomes 7 times 3 plus z equals 28. So I've got 21 plus z equals my 28. So z is equal to 7. Here is my second answer. I now have two results, so I can take my two answers and I can come back over here to one of my equations out of my three variable system, choose whichever one you like the best. I'm going to go ahead and work with the top one. So we have 2x plus y plus z is equal to 6. Input what I know. 2x plus 3 plus 7 equals 6. So this is going to give me that 2x plus 10 equals 6. So my 2x is equal to negative 4. So x equals negative 2. Now, in order to state your solution, so your solution here has to be written as x, comma y, comma z. So here my actual solution would be negative 2, comma 3, comma 7. And this would be the result that you would be looking for. Now you want to take this result and you want to check your work. You want to make sure that you did not make any mistakes along the way. Okay, so always, always, always check your work. Look for problems. Now, one thing I wanted to do with this three variable system here is I wanted to show you all that there is a different approach that you could have taken with this system using elimination still and still come out with the exact same answer. And so I'm going to show you that here. So again, we had our system, which was 2x plus y plus z equals 6. And then we had 2x plus 3y minus z equals negative 2. And we had negative 3x plus 2y minus z equals 5. Now in that first example, when we looked at this system here, we got rid of the x's. However, take a look at the z's. I could get rid of my z's without having to do any extra work. So here again, I could use my top equation, 2x plus y plus z equals 6, and the second, 2x plus 3y minus z equals negative 2. And instead of having to multiply top or bottom, I just simply go. So here this would be 2 plus 2 is going to give you a 4x. 1 plus 3 is plus 4y. My z's go away and this is going to equal 4 as a result. Now you want to simplify. I can divide everything by 4, so this gives me x plus y equals 1. So here would be my first two variable equation. Again, I can go back, I can use the top and I can use the bottom. So let's go ahead and do that. So we're going to have 2x plus y plus z is 6. negative 3x plus 2y minus z is 5. Add them together, old school all the way. 2 plus negative 3 is negative x. 1 plus 2 is going to be plus 3y. My z's go away. 6 plus 5 is 11. There is my second equation. So here what this says is that we now have the new system. And that new system is going to be made up of x plus y equals 1, negative x plus 3y equals 11. Here's my new system. If you look at this, notice if I just add my system together, the x's will cancel, so I'll go ahead and do that. So here we end up with 3 plus 1 gives you a 4y is equal to 11 plus 1 gives you 12. So y is equal to 3, and look at that. That is the same y result that we got in the first example. So if you keep going, what you'll notice is you get the exact same solution, but here we started very different. Okay, so like I said, there are many ways that you can solve systems. There's many different approaches, and even within a single approach, there are still many different starting and stop points. You just have to approach it the way you like it the best. So there you go. If you have any questions on a multivariable system greater than 2, please let me know. If you have your own 3-variable system you're struggling with, you need some help, send me that as well. I'd be more than happy to take a look. Otherwise, I hope you had as much fun as I did, and I really look forward to seeing you next time. Enjoy!